Hello and welcome everybody to today's protection course in electrical power systems. I would like to talk to you about overcurrent protection and especially about the overcurrent protection in ring structures. So what is a ring structure? A ring structure can be seen to my right side. It consists as in a normal grid from the feeding source. This is a transformer on the feeding busbar, and then we have two lines that go in parallel to the consumer's busbar, which is located at the right side. The protection in this case should consist of 4 protection devices, 2 at each end. And these protection devices should, especially on the consumer side, be directional sensitive. That means they must compare the direction of the current, that is the phase relation between voltage and current, and this is indeed done by establishing a voltage transformer connection. So how are the current versus time dynamics? As given in the basics about overcurrent time protection, we can see that we start again from the normal situation, normal operation situation of the network, which is given by nominal currents or below, nominal voltages, maybe a slight excursion into the overload range and then a recovery. And then with a fault incept, we see a high current of approximately 5 kiloamps, which flows as long as the tripping time of the protection device allows it. Then the short circuit is tripped out and the network is restored to its normal operation, except this faulty feeder. So the protection dynamics in a ring structure are more or less the same. So we have the ring structure again, and please note that the protection relays at the right side, at the consumer side, they have the indication, this arrow indication, the direction indication, and they have a very low time setting, 0.1 for example. So if now a fault occurs, we have the fault current of 5 kiloamps entering the medium voltage, the distribution network. It splits up into the 2 lines that feed into the fault, and for example, if the fault is at the end of the line, then the fault current is split up 50 to 50, and we have 2.5 kiloamps flowing through each of those feeders. All the 4 relays will pick up at once because they see more than their nominal current, and the protection relay with the shortest time will act first. So the shortest time is given at the right side. One relay, the upper one, has the correct direction. That means the direction against the normal load flow into the source. And the other, the lower relay, has the so-called wrong direction. So the one with the right direction will trip out. That's given here. And we have the standard situation of a radial feeder fault, which is cleared after 0.4 seconds by the overcurrent time protection. So after that has been tripped out, the overcurrent situation has disappeared, the voltage has recovered to nominal values, and the current flow to the sensitive consumer is re-established through the lower of these 2 feeders. It comes in, goes down, and comes to the feeding busbar. So this was the lecture about the overcurrent protection in ring structures.